Hello, everyone. Welcome to the binary episode of the podcast for this week. I'm Spectre, with me is Z. Let's cover the Spot the Vuln challenge for this week, and then we'll get into our topics.
Yeah, so this week's Spot the Vuln is actually, as was just put out in chat also by um Mayraz. I'm sorry. Got there as being on line 14 when it sets a list count equal to null, just setting that last null indicate the end of a list or something like that. When it's setting that, that is technically an out of bounds right because we only allocated space for count items, but that access is going to be one beyond, because of zero based
Off by one
indexing.
issue.
Yeah,
Yeah.
exactly. Off by one. I did see a few other things kind of get called out too. One being, obviously the malloc could fail, and that could be a null pointer dereference. Um, which is fair. I just don't tend to include those as in some of these challenges. That's mostly just to keep the code somewhat concise, but it is a fair thing to take notice of.
Yeah, could probably have the same issue in like the new widget, because I imagine that's going to be allocating too. So
Yeah. I guess the other thing is that count completely depends on what max size is defined as, which I didn't show here. That allocation count times size of could overflow also. So if that overflows, you could have a too small allocation.
yeah, Myocat said, "Isn't it supposed to be size of count?" So basically, what's happening here, like in this code, is it's allocating an array of widget pointers. So it's allocating count times the size of like a pointer to a widget, so 8 bytes. That's basically what's going on there.
Yeah, it's pointer to a pointer.
Yeah, exactly.
So in theory, new widgets doing that allocation of size of, or I guess size of count. Sorry, I misunderstood what you were going for.
So with that out of the way, we'll get into the Humble Bundle that was put out recently. So Z, I know you have some stuff to say on this because I saw that you posted a Reddit review, kind of breaking down the books that are in it, and overall, I remember you saying that you thought it was like a decent value. So I'll let you go ahead here and break it down for those listening who might not have seen your post or anything.
Yeah, and I'll try and keep this mostly to those of you who might be interested on the more binary side. And yeah, usually, at least with the no Starch press bundles, I'll kind of review the books I've read because I've been over quite a few of the no starch books. Less so when it's like packed, which generally just has like a worse reputation. Short version of this, it looks like a good bundle. If you're not, if you're only into it for the binary, I mean, there is a Ghidra book. It's not the greatest on that front. There's practical malware analysis, which I mean still gets recommended when it comes to reverse engineering and more the dynamic analysis side of things. It is a bit dated. I want to say that that one's like 2012 or maybe it's 2014. I don't have the date with me. Um that said, I was also surprised this ethical hacking hands-on introduction to breaking in was a positive surprise in terms of books. So at first glance, I thought this was actually a Georgia Weidman's book, which is penetration testing. I forget what the subtitle is, but it has hands-on in there also. Ethical hacking is a recent book from just this past September, and it is an introduction. So if you already kind of know what you're doing, it's not really the greatest book. It's not a great introduction to any particular topic. Like I wouldn't say start there. But what surprised me about is the fact that it's actually covering a lot of different topics within ethical hacking. When I see that title, I'm expecting that to be a network pen testing book. Because, basically pen testing, ethical hacking have been the term's been hijacked. It covers a lot of things. It covers things like crypto. It actually, I was surprised to see like a fuzzing section, vuln research, where it even gets into like symbolic analysis. It's fairly recent stuff. Um, cloud cloud stuff's in there, of course. And of course, there is some on network pen testing, but it covers so much more than that. It was just a positive surprise. Again, I wouldn't recommend if you're learning one of those in particular, but if you're new to the field, perhaps it seems like a decent book for just getting an overview of the different areas. A lot of times you are just kind of getting a lot of ethical hacking resource push you to pen testing. Um, Practical IoT hacking also kind of surprised me a little bit. I've only reviewed that book just in passing, not too in depth, but has a lot more on methodology than I expected. I mean, IoT kind of has the security or insecurity implications, well known for being insecure. It's better than I expected. Oh, Serious Crypto is one of my favorite books in this set. Again, maybe less applicable for binary, but rootkits and bootkits. Oh no, Spectre, have you read that one?
No, I didn't. I
Oh, I
remember
thought you had.
seeing it before, and I think I expressed interest in wanting to read it just because of the topics. Like, that's probably the most low level book, maybe aside from the Geecher book in there. But yeah, I just never really got around to it. Uh,
Yeah, fair. It's I've seen it recommended quite a bit. I haven't personally reviewed it though.
yeah,
Um Attacking Network Protocols, I mean that's by James Forshaw.
yeah, you're not
It's
really getting a better expert on the subject.
yeah, not at all. It's a solid book. Black Hat Python. That is the second edition, so that is Python v3, not v2.
Oh, okay. So yeah, Black Hat Python is one of the books in this list that I have actually read. I actually have a hard copy of that book, and it covers some interesting topics. But again, it's more like that beginner focus, like talking about scripting up reverse shells and some of the things you can do with Python. Um, and yeah, for that reason, I remember a little while ago we were kind of interested in Black Hat Go when that book came out. Although that seemed to be a little bit disappointing when we looked at it, unfortunately.
Reality was
Because
disappointing, especially since it got delayed for like 2 years.
yeah, there was so much hype built up around it after the delays and stuff.
Yeah.
So yeah, there are also a few books in this bundle that I think you actually pointed this out that are like pretty old at this point. Like I think Practical Malware Analysis. I remember looking at this book a couple years ago.
So on a whole,
Um,
this is a new bundle. Like most of these books, I think it's 11 out of the 18 books are from within the last 3 years.
yeah, but there
There
are some
are
of
a
those
couple.
outliers.
Practical malware
Um,
analysis, traditional. It's often recommended. Well, maybe not often. It is still recommended pretty actively. The other old one is the Tangled Web. That's 2011. Kind of fun web stuff. Like it's still applicable, but there is newer content. It falls kind of similar to Web App Hacker's Handbook. Maybe a little bit even less relevant now. If I were to drop any book definitively, it would be that one. It's not a terrible book, though. I mean, a lot of fundamentals of the web have stayed the same. Practical Forensic Imaging is the other old one, which I have no idea about. That is not my realm at all. Uh, Everything else is either recent or there are two slightly older ones, Serious Crypto and Attacking Network Protocols. But they're still relevant. They're not dated.
yeah, I mean the reason I called out the Practical Malware Analysis specifically is because malware is one of those areas where it's fast moving and there's like it moves more quickly than perhaps some other areas. That said, there is a good deal of other like malware based books in here, like rootkits and bootkits, and I think there's two or three other ones that are centered around malware there. But yeah, like some of those older books might not be like as interesting.
Yeah, I
Um,
mean, you're not wrong in terms of malware moving quickly, but practical malware analysis, I think, has the benefit of kind of being RE from the dynamic, so reverse engineering from the dynamic analysis side of things. So it has something different going for it. I mean, yeah, malware's moved, but malware analysis maybe a little bit less so. I don't know. I mean, that also isn't really my wheelhouse. But like I said, I still see it recommended at least. In fairness, I still see hacking artifact exploitation recommended too.
Yeah, we have a video on that from like a year ago, and even at that point, we were saying it was a bit too dated. But yeah, overall, like this looks like a solid bundle. The price is a little bit higher than I expected from like a security humble bundle because you have to pay like $37 Canadian minimum to get all the books, all 18. If you go under that, I think you only get like uh, actually, let me just
Well,
check
so
so I can
you
tell you.
don't get ethical
You get
hacking.
9 of them.
Yeah. You get
So
about half the bundle.
yeah. And the Ghidra book is like the big one that's missing that you don't get if you don't pay the full threshold. So the threshold is a bit higher than I expected, but I mean, the big benefit with Humble Bundle too is like a lot of that money goes to like charity, and you can kind of choose which charity it goes to with like sliders and stuff. So you get a good deal of control over where that money goes, and that's like the main offering of Humble Bundle. So yeah, like I can't really see anything that would make me say like don't get this bundle. It seems like a reasonable offering. So I did want to pull a question out of chat, which is any book recommendations for kernel exploitation. There's not really many. Um, a fundamental one that I would recommend to anyone who wants to do it is Modern Operating Systems by Tannenbaum. It doesn't really talk about exploitation specifically, but it goes into a lot of background on operating systems, and it'll talk about critical components like file system, scheduling, all that stuff. And you're going to need to know a good bit of background on how operating systems work if you want to be proficient in, bug hunting in it and exploiting it.
Yeah, I mean,
There
go ahead. Sorry.
Yeah, I was just going to mention there is also a like a guide to kernel exploitation attacking the core, I think is the name of the book.
Yeah,
There is also that book, but that is pretty dated. A lot of
2010.
the code, yeah, a lot of the code samples they have in there are vulnerabilities that you are not going to find in 2021 in any modern code base. It's very like 1990-esque buffer overflow style. Like we just like they did a mem copy and didn't check the size or something. Like I don't think it's really too relevant to the modern kernel landscape. But that's something you could check out if you really wanted to as well.
Yeah, I mean,
Um,
at best, you do maybe get a bit of the paradigm shift between user and kernel land out of the book. Um, Out of attacking the core, that is. Of On a whole, though, like there aren't a lot of books that really get there. I agree with you on modern operating systems. I've been hearing a lot about operating systems in 3 easy steps a bit more recently, and I believe that is free also. I haven't read that one though. On modern operating systems, kind of like Spectre was saying, like it's not teaching you the exploitation, but it's giving you the foundation need to understand the kernel so that when you go to attack the kernel, you kind of know what's going on, what they're trying to do with any of the code. 'Cause, I mean, it is complex. There's a lot to it. I'm kind of a big fan of you understand what your target is. That's how you kind of get into or how you get into trying to exploit something is by understanding how it works in the first place, perhaps how to build it yourself. That's where I'd agree with modern operating systems. That was actually the textbook for my university operating systems class.
yeah, so it's kind of funny because I brought up this criticism with attacking the core that it's kind of dated, and modern operating systems is
Oh,
like
they have
somewhat dated
updates.
too.
No, there
Um,
are updates.
okay, they're
It's come
updated,
out
but
more recently.
right. But what I was also going to mention there is because of how operating systems work, a lot of those concepts, even if you didn't see the updated editions, are very applicable to modern computers. Like schedulers and whatnot generally haven't changed a ton. Like they still had to encounter the same problems, right? So, like, one of the main things you'll learn from the modern operating systems book is like producer consumer type problems, because those are probably the hardest problems to deal with in an operating system, especially when you're talking about multiple processors and multiple threads. Um, Getting producer consumer problems is like the basis of a lot of kernel code. So those problems haven't gone away over the years. In fact, they've just become like more difficult to deal with as people have tried to write more efficient code. So even though the book might be a little bit older, although it's been updated, as Zia said, those concepts are still very much relevant. Whereas attacking the core is a lot more example based, and because of that, where those examples are dated, they're just not too useful, I think. Um, but yeah, those are the only two books that really come to mind. There might be some others that I'm just not really aware of that have come out since, but yeah, I haven't really heard anything about them if they're out there. I think kernel, like exploitation in kernel and browser and anything like that, books just aren't really the best medium for that. Um, you're mainly going to be looking at like write ups and referencing things like that for
Yeah,
learning
and
kernel exploitation.
we have that series on like just learning modern exploitation, like our discussions on that. It kind of comes down to the fact that like you learn your exploit dev, you learn the vuln research, and then you apply to your particular target. And that just is learning your target, learning the existing research, so looking at past exploits, past vulnerabilities also. Not so much like, as you're saying, things move fairly rapidly, and it's such a niche that you're not really finding books on like that specific topic.
Yeah, it's just not the best medium for it. Um, but like I think the technical books, like this is getting a little bit more broad in general, I guess, but technical books I think are better for explaining background on a target, like the modern operating systems book. But not for like the vulnerability stuff. For that stuff, I'm just I don't really find myself referring to books as much because I just don't think it's as useful in that regard. So.
Yeah.
All right. But yeah, with that said, we'll move into some of our exploits for this week. So up first, we have one of two Project Zero reports. The first of which is in KVM when using Secure Encrypted Virtualization Encrypted State, or SEVES. It's an out-of-bounds access in the VMG exit handler, which is triggered for string I/O operations. The bug is in SEVES string I/O for doing the string copy between unencrypted guest memory regions and the virtualized target. What happens there is it'll set up a scratch buffer called SVM GHCBSA, GHCB being guest hypervisor communication block, and it'll set it up using guest controlled values for the length, the I/O access size, and the contents of the scratch buffer. And when the control flow eventually gets to emulator PIO out for outgoing IO, it copies the contents of the scratch buffer to the virtual CPU PIO data using the IO access size multiplied against the provided length. The problem is that PIO data is only going to be one page in size. So if you provide a count or a size that makes the memcopy go beyond one page, there's an out of bounds access where you're reading from or writing to an adjacent page as memory. Since that happens on both input and output paths, that yields an out of bounds write and read, which is a powerful pair of primitives to have. Um, but yeah, as you'd expect, the patch here was just to ensure that you couldn't provide a size that would exceed the page size of the system. There were also some other changes that were made in the patch that they linked to, but those didn't really seem to be too relevant to like the vulnerability here. The vulnerability was just the fact that you could write more than one page in the string IO copy. So
Yeah, I
yeah,
mean getting the read, like they kind of call out here that for requests that use scratch buffer outside of the GHCB block, basically anything that sets the size beyond a value of 1 would have triggered the bug. So like they kind of call out here like they're surprised that this wasn't noticed before, because it would have been many operations that could have hit this. I mean, perhaps because they'd start with the right data, nobody was really taking note of it, and if you weren't running it with ASEN or something. But I kind of agree, like it is odd that it wasn't noticed before.
seems to indicate that their testing process doesn't involve like fuzzing or anything of that nature, because this seems like one of those bugs where as soon as you throw a fuzzer on it, it would be found immediately. So Yeah, it might indicate some weaknesses in their testing processes. Uh, but yeah, I mean, mainly why I wanted to like make sure we covered this issue is because KVM is just one of those interesting targets where you're talking about virtualization. It's a very complex code base. It takes a good deal of time to understand what's going on there.
I mean,
Um,
KVM, like, it's mainline kernel, is it not? Like, yeah, the
it is
patch
in the
here's
mainline kernel. Yeah,
yeah, like the patch here is kernel on kernel.org's like in Torvald's branch. So I mean, it's mainline kernel, so that in theory, like Syzbot's always fuzzing Linux kernel, is fuzzing Linux next. I don't
it's
know if they
probably
have
not
any
targeting KVM very
instructions
well.
on. Yeah, I was just going to say that. I don't know how much it's hitting KVM, but there definitely are, the kernel fuzzing projects.
Yeah, that's an interesting question. Actually, I should have like looked into Sysbot and like just out of curiosity to see how well it's actually hitting KVM. But uh,
Yeah, I was actually just pulling up the syscaller.
the repo, okay.
Yeah.
Um, but yeah, like I was saying, like KVM is just an area that is pretty complicated to understand, and I feel like a lot of people just glance over it. They might use it, but they don't really care much about how it works. So it's fun seeing bugs in areas like that. Um, I see you have the KVM
Yeah, although
definitions up.
I guess that is like creating the VMs and stuff. So like all the syscalls are being kept by syscaller, of course, but this
But
was
like at
a
runtime
guest a
stuff isn't
host
really being hit.
thing. Yeah, I could understand why this actually isn't getting hit too well by something like syscaller. You have to be fuzzing kind of specifically to be looking at that.
So basically, it's hitting the interface, but it's not hitting the actual virtualization code. Like,
Well, I
it's only
just
hitting the
glanced
setup
at
code.
it.
Yeah, but I was reading it too, and it seems like it was a lot of like the ioctals and stuff for like
Yeah, which I mean
interfacing
is
with it,
what
not the
syscaller does. Yeah.
yeah, it's not really doing the virtualization too well. And for what it's worth, like BPF kind of has the same issue. BPF can be hit by syscaller with the ioctals and whatever, but when it comes to the actual filter programs that get ran, it's more difficult to target that because it's kind of a specific uh,
It
and
takes more
non-trivial
setup
interface.
too. Like there's more context around it. So yeah, I guess that at
Yeah,
least why syscaller wouldn't be hitting it totally makes sense. I just forgot about that kind of in the moment. Was just thinking about, oh, this is such a seems like such an easy thing to hit, but there's the context around it. No doubt. So well, I guess I can't say no doubt, but I feel like this could be one of those things that was this could even be actively used just because of the fact that it feels like it should have been discovered had you been fuzzing KVM. KVM's pretty common to see in like VPS providers and such, so I could imagine it getting hit. Obviously, it's not in the same context as like just hitting Android or something like very valuable Ode, but yeah, I don't know.
yeah,
I mean, definitely stands out though.
yeah, for sure. So up next, we have a Talos report on an out of bounds write in Anker Eufy. I'm just going to say Eufy. I don't know how you're supposed to say that. Homebase 2's CMD device get server list request command. This details one bug that exists in two different places. They do go into like a good bit of detail on reversing of the protocol and some detail on the structure of the command, but yeah, I don't know how much we want to cover that. But Z, I'll let you explain the bug here.
Yeah, and this one is, let's mention with Homebase 2, this home security binary, it communicates with a cloud provider, or it just comments on the, not cloud provider necessarily, but cloud connectivity occurring between whatever IP on UDP port 8006. And this is kind of what they will be focusing on is that UDP access and kind of the response from the cloud server. So they kind of end up switching between when they're talking about request response, like it's the packets coming from the cloud or coming from outside. And what they found here, the gist of it, the response generally they'll receive data from the server. It contains JSON. They pull some values out of that JSON, such as num being one of the fields. Let me see if I can find. Yeah, here we go. Nice big block of code. They just pull an integer out of their nums, and they use that a little bit later here in this for loop, where they're just iterating on that many number of values. So this is UDP servers addresses that it's expecting in there, and then it just kind of uses inside the JSON also, though they only have the config file here showing. It'll send like domain one as the key value for it, the actual domain as the value. Out of chat, my AO cat's saying, God, what code? My eyes. Not the nicest code, but I'm pretty sure this is the compiler code. Actually, I am confident that this is Binja output. And I'm saying that because I see this zx.d, which is, Binja's indicating the not the comparison, the size conversions. Similarly, you've got this s indicating a signed comparison. So
Yeah.
pretty sure
So
this is just go ahead.
yeah, I just wanted to elaborate. Like ZXD, for example, is zero extended double word. That's kind of the
Yeah.
short form for anybody that might have been wondering there.
Yeah, so this isn't quite what they would have written, I hope.
Never
um
know.
that said, getting into the actual issue, it really comes down to, I guess, first of all, it's no bounds checking. Really, they grab this nums and they just act with that. They don't actually do any sort of bounds checking on it, and they have a fixed region of memory that they are eventually writing to. The way it gets there, it reads out this nums, it uses that as its for loop, so it has the counter, and then it'll ultimately be iterating on the nums. Comes out UDP server. It iterates through that X number of times, given what you give it. And the idea is it's going to clear the scratch buffer that it creates, just this 80 byte buffer, tries to read the domain 1, 2, 3, 4, etc. until through all of the numbers in there. If it doesn't find that key, it just skips it. If it does find it, what's important is it'll do a mem set, and then it'll do a mem copy into that. So that's where you're getting your write from, or it's writing to that address. Little bit weird that it does the counter left shift 7 bits, and it's just actually these two mem sets are going to the same address, just in different orders, gain hinting towards the whole decompiler output. Oh, it's effectively doing whatever the index is multiplied by 128. So you've got that gap of 128 bytes for everything. But ultimately, you control this value. You control num, so you control at least one of the values, or one of the entries in the JSON. So you control how many times it's going to iterate. Basically, you can get control of this mem copy, and you can write whatever the value is for that key. No more than 80 bytes, but you can write it pretty much anywhere you want, given the fact that it's doing this offset calculation of by 128, and it has the static starting address. The fact that it has a static starting address, I'm assuming no ASLRs in play. Otherwise, that would not really be possible to do.
Yeah, because
Yeah,
if it was
arbitrary
compiled
right.
as like position independent, you would see that in the decompilation.
Yeah, you wouldn't see a static address being used to calculate. I basically this seems like the index into an array. Since it's
Yeah,
jumping by the 128. I would assume that's kind of the code. Is this is just indexing the array by it. Doesn't do the bound checking. So simple enough issue. Kind of fun because of how it comes. Like you do get this arbitrary right. It does need to iterate through it a bunch of times, but because it doesn't actually do the right except when it has the matching key, like it actually finds it in the JSON dictionary. Kind of fun in that sense. Otherwise, though, it's a straightforward issue.
Yeah, and it's worth noting that the same issue also exists in the read UDP push config file path, but it basically gives you the same primitive. But they did shout that out in the report.
So
Um,
out of chat, my AOCAT asks, sorry for asking, but how do you control it? Like by what input? Yeah, so this is a on the device itself, it hosts a UDP service that's listening on port 8000 and whatever I said earlier. And that usually is getting updates from, and I believe it also communicates bidirectionally out to a cloud service. Whatever it is, they give the IP for. It's communicating there, but it's UDP. You could send whatever messages you want. You can spoof those if you want to. It doesn't actually indicate that they need to spoof, so I assume it's just listening for traffic from anybody and doesn't validate the IP at all. So basically, you can just send it these JSON messages. Because it is a cloud thing, it's expecting that these are just receive. The function name is receive server device response message process. Doesn't seem like you actually need to. It doesn't have to actually have been the response to the server. So seems like you can just send the message out. That's what it comes down to.
Something else I thought I'd pull out is like, no, I think a syntax highlighting would be great. Like everything is orange. So it's kind of funny because Z and I were talking about this, I think yesterday actually. Yeah, I think it would be nice if Talos worked a little bit on how they display code on their site, because not only is everything orange, and like while the color scheme of like dark black or dark gray and orange is nice, it's not the most readable, and they have like text wrapping going on, so it's like it makes it extra hard to read.
Text
Yeah,
wrapping is the worst on this. Like, like who does this? Who
it's
wants their
cursed.
code like that? Like, especially because it doesn't have any innate knowledge of the line numbers or whatever they're using in this case, offset. It makes sense in an IDE where it does still kind of display it properly ish. Yeah, I mean, it, they don't put much effort into these. We're not paying clients of theirs. Fine. I would assume like their real reports look nicer. I would
Yeah,
hope.
if I had one wish though, I would wish that like code was more readable in these, because yeah, I mean, there's been some cases in the past where I've literally just been like, screw it, and I pulled the code into like my own like Sublime text or whatever, because I was like, I'm not reading this on the site. It's terrible. Uh, But yeah, that's just like a bit of a gripe with how they display it. The report though here is pretty good. I think they do like I said at the start of the topic, they do go into a good bit of detail on the reversing aspect, which is a little bit weird. Um, like I was kind of saying this to Z too. Like with Talos reports, it seems you either get like a bunch of information on like background and reversing and everything, or you get like a crash dump and that's it. It's kind of, you don't really get like in between. It's either a bunch of information or none. But yeah, if you're just interested in the issue, you could probably skip like a lot of the where they break down like reversing the packets and stuff, unless you
Yeah.
find that interesting.
When they have it though, like what they tend to do with their reports, which is kind of nice, is they show the data flow from input to vulnerability. That's kind of where you end up getting all the background as it's explaining how they got the input there in the first place and kind of the path it took, explaining all the things along there. That tends to be how they do when they include information. If it's just the crash dump, obviously it's not there, but it is a kind of nice structure too. Like it has some reasoning behind just being the data flow effectively.
Yeah. All right, so we'll get into our second Project Zero report here, which was an Apple issue in ColorSync, which this issue was found by fuzzing the ColorSync system library, which is used on both macOS and iOS. Um, Fairly straightforward issue here. What they found was that when calculating the start address for reading from a color lookup data table data point array, it would do an array access multiplying the x coordinate in the image by the y coordinate times 2. But if the number of in channels in the header is set to 0, that y value never gets initialized, and it's left to whatever value it inherits from whatever was on the stack before it, which, if that's a large or negative number, will lead to an out of bounds access when accessing that array and causes the crash that the fuzz are found. So just seems to be one of those edge cases where, an unexpected header value leads to a bit of code being skipped, being the initialization of the y variable, and it leads to
Yeah,
an issue here.
it's the reason why the y variable doesn't get initialized is it's effectively initialized it in the inner loop. So the y iteration being in there. So when you do have the no channels, goes by 0, messes everything up. So unexpected, but it's also kind of just a fun little issue where you have, and I guess I like that phrase, fun little issue, but where you have just that inner loop not running and they expect it to. Like under normal circumstances, inner loop runs, everything's fine. Break that violation or violate that assumption, and you've got the uninitialized use. It's yeah, I mean it's fun. It's a simple enough issue, as a lot of what we've talked about today has been. But it's
It's
still
a
a great little
little
thing.
it's a little surprising how simple of an issue it is, given the fact that this is in an Apple library. Generally, Apple's like practices when it comes to development and whatnot try to catch these types of issues before they go out there. Um,
This isn't like I guess it's not something we haven't seen before. Like we've seen these sorts of issues when it comes to like channels in particular, in like image data and visual data.
Yeah. I mean, so I was going to kind of balance out what I said there. So, while this does seem like a somewhat trivial issue as far as like Apple products go, at the same time, this type of library is the prime target for fuzzing. Like this is file format fuzzing 101 basically. So, it's not surprising that fuzzing is still able to shake out these kinds of issues. Like image parsing is hard. It's not like it's way harder than you would expect it to be given you look at color and it's like it's just color, but because of all the different specifications and all the different implementations that have to be supported, there is a lot of like areas for issues. And yeah, I mean, it's not surprising at all that this was found through fuzzing. Um, and we do like to cover like
Yeah,
the
I
methodology
mean,
when it's available. So
in fairness, like I'd have no idea. Like if you just showed me an ICC or an ICM file, I'd have no idea what it was. Um, like at least when it's like PNG and stuff, I know that. Color profile, I've never needed such a file.
yeah, it
I
is a bit of a
mean,
weird area too.
yeah, it's not going to be as hit as the more common fuzzers, especially because this isn't something you would just send over like Messenger when you're looking for Messenger vulnerability.
Yeah.
Out of chat, Maharaz asks also compiler states compiler normally detects for you non-initialized use of memory. Fair. I mean, if you had it can. I don't know. I mean, I guess that's going to depend on what level of warnings you have set up. It definitely can do it.
Well, the thing is, too, the compiler is pretty naive when it tries to find those issues. Like, if you have a blatant uninitialized use, it will detect it, like you're saying. But if you have something where one path will initialize it, but another path won't, like, it's not going to be able to detect
No,
that as easily at compile time.
I believe Clang can call this one out. Um, and being Apple, I'm assuming we've got Clang going on. Uh,
Yeah, I'm
I
not
mean,
saying
this
it
one
can't
could
do it.
inner
I'm just saying
loop.
it might not be able to catch it, or it might not be as like obvious to the compiler. I need to test it to be like 100% certain on that.
Yeah, like I'm saying, I believe like just being the inner loop type deal. I guess you would declare it outside. Inner loop doesn't initialize it. I feel like that's something I've seen Clang warnings for. Maybe I'm mistaken about that. Actually, you know what? I think I am mistaken about that. Um,
Yeah, it's actually something I like. If I had the time right now, I would actually go and test it because I'm
don't.
curious. Maybe after the stream I will. Because
Yeah, I mean, it's definitely feels like something that they could catch, but
yeah, I mean, if there was a compiler that was able to detect stuff like that, it would be Clang because as Taniwan chat says, like LVMIR is very like powerful, and the types of analysis passes you can do are insane. You're basically like unlimited. So yeah, it wouldn't surprise me if Clang could do it, but that's something I want to test. But yeah, I mean, I guess we can jump into our last topic here, which is a write up by Justin Sherman on iOS kernel exploitation. So this bug was the write-up focuses on exploiting an out-of-bounds read that leads to type confusion in the IO surface subsystem. The bug, though, was detailed earlier this year by Sarah Mar in July. Unfortunately, that was during our break, so we didn't cover it at the time. Um, as such, this post doesn't really focus too much on the vulnerability, though I will briefly cover the basis of the bug without going too in depth on it. Basically, the bug is in an external method of IO mobile frame buffers called sDisplayedFB service. When this function executes, among other things, like copying an entitlement, it'll call into this getDisplayedSurface method on the scalar input, and there they take a user-provided index via scalar0 into the like scalar array, and there's no bounds checking on it at all, allowing you to get out of bounds read on an array of IO surface objects, which then gives you the ability to get an arbitrary pointer interpreted and used as an IO surface object, right? Because you can use the out of bounds read, get it to like index out of bounds at the table and get whatever data is there interpreted as an IO surface pointer. From there, that's where this post starts, talking about, what code paths do we hit that will use that fake IO surface object. And the only path that will be hit consistently is the IO surface send write classes init IO surface root IO surface method. There, it calls a few different methods that are interesting, such as client retain, which will increment a reference count at offset hex 354 of the fake object, and increment use count, which gives a arbitrary 32-bit increment at a pointer that you could control at hex C0 of the fake object. The post then goes into a lot of detail on iOS mitigations and heap isolation, which I don't think I'll cover too much of here because it's very specific and it's not something that I'm super familiar with. That said, it is a very interesting section. Like, I don't want to dismiss it and just say like don't read it, because it's very interesting.
Yeah,
The
what
basics of it, though. Go
I'll
ahead, Z.
just toss in is like, as a post, when it comes to the exploitation, it doesn't assume a lot of knowledge. And actually it is kind of nice also because it does talk about the thought process behind like what they're looking at and why. Like, it starts off as a little bit you just covered there, the initial recon. Um and that's roughly like the same order I look at a bug. You've got the bug. What primitives do you gain by it? Now, what requirements do you need to meet in order to actually hit any, like, not panic early? I thought it was a good post kind of on that meta side of things. So I just want to, I guess, shout that out here.
Yeah, you get a lot of insight into the exploit methodology. Um, but yeah, so the basics of like the mitigation section is the fact that iOS has something called K-heaps that got introduced in iOS 14, and that allows them to isolate allocations into their own heaps. So, for example, you have like the data buffer heap for data that's copied from user space, the default heap, a heap for kernel extensions to use, and a temporary heap. And critically, those zones are somewhat isolated on the submap level, and they're sequestered. And what that means is it's basically impossible for a page to get released to the zone allocator and get used by a different zone, because that is kind of the common strategy when it comes to bypassing zone isolation. Is you just try to allocate a bunch of stuff, free it all, get a page released back, and then reclaimed by some other cache that you want to hit. But the problem is that doesn't really work here because of this new mitigation. They did find a way around it, though, and that is the fact that really large objects that are larger than 32 kilobytes will take a path that will ignore the k-heap isolation and sequestering, and it'll instead just allocate directly from the kalloc map or the kernel map. And luckily, because of how the VM map find space function works for allocating in the VM map, it'll look for like the first suitable hole it can find, meaning it's fairly deterministic as well. With enough heap shaping, you can get contiguous allocations and predictable ones, which is very useful for guessing kernel pointers in something like the kernel map, which is useful later on. The spray object they went with here was OS data buffers, which they sprayed about half a gigabyte's worth of, striking that balance of not being too time consuming to spray that much and still being like clearing the threshold of appropriately shaping the heap. After all that, you can use the OS data buffer to heap spray and get control over a fake IO surface object. And the write-up delves into like what do you do with that now that you have like this fake object set up. Well, they found that there's an external method, being IO surface root user client's get surface use count, which will read the use count of the fake IO surface, which allows a 32-bit arbitrary read primitive, because you control the pointer that would be used for that read, where you can create a fake IO surface object. Similarly, the set compressed tile data region memory use of plane. These are very long method names, by the way. But that method of the IO surface root user client class would perform a write using that pointer. So that gives you the arbitrary write half of it. There was a good deal.
Given that
Go
you
ahead.
commented on the size, I take it you don't write much Java.
No, thankfully I don't.
No,
No,
this is. I mean, Objective C
especially
kind of leads into that too a bit. I mean, I the C++, but I was thinking kind of Apple land.
yeah, especially in the kernel, like these are pretty long function names. Makes it a bit weird
Correct.
trying to
Yeah.
like cover them. But yeah, there was a good deal more to getting the arbitrary read and write set up and useful. For example, like getting completely user controlled buffers close to the OS data buffer for the arbitrary read write, which for that they use pipe buffers. If you're interested in those details, though, it'll be way easier to understand reading the write up and following the various diagrams that are there to explain the memory layout. So I won't really go into too much like covering that verbally. There was also another neat way this researcher took advantage of the type confusion and the 32-bit increment, which I want to quickly mention as well, which was abusing the way the IO surface client object was used. Basically, this object would contain a child pointer to the IO surface object it manages, as well as a parent pointer to its like root user client. And most functions would get the client array from the root user client, index into that with the IO surface ID, and pass the IO surface pointer from the client for any work that needs to be done, like to any functions. And they thought, like, what happens if using the type confusion, instead of passing an IO surface pointer there, you pass a IO surface root user client pointer. So trying to cause another type confusion, basically. And by doing some careful heap shaping and abusing the 32-bit increment on that pointer to shift the IO surface pointer to point to root user client memory, they were able to leak a bunch of kernel pointers, including the IO surface root object, the root user client, and the surface client array. So I think the researcher mentions like that's their favorite like derived info leak that they've seen. And it is very cool, basically using your type confusion to induce a more like a better one for info leaking. So yeah, I mean, a lot of really cool details here on complex iOS heap exploitation, and a lot of internals on the heap hardening work that's been done on iOS, which I wasn't really aware of. I wasn't aware of these heap isolations mitigations that Apple's been working on until I read this write up. So yeah, I mean, also just a really great write up. Like I hinted
Yeah, a
at
lot
earlier,
of
there's a lot
background.
of
It does almost feel like it rambles a little bit. When it's including just like, thought about this, had to try that, but that information's valuable. In terms of giving more of the mindset to the exploit dev.
the other thing I wanted to call out was there's a lot of diagrams here and whatnot that help illustrate the heap state, which is very appreciated because this is a very complex exploit chain. It involves multiple different types of objects, different types of heaps. Um, like trying to visualize that is pretty much impossible if you're just reading it. So the diagrams that are in there go a long way in you know helping you visualize what's going on. So yeah, I mean, just a really good write up. And it's also a great thing to point to if someone wonders what's involved with a modern exploit chain on hardened targets. This is the kind of like thought process and methodology that's involved there. Um, Type confusion is a huge like thing that you have to learn how to take advantage of when you're dealing with memory corruption, because a lot of bug classes ultimately you're abusing type confusion in some sort of way. Like in this case, they're abusing the fact that there's an out of bounds read that allows them to fake a pointer to an object, but like a use after free, for example.
Well, use
Ultimately,
after
that's
free.
abusing a type confusion at some level.
Yeah,
So
like you're creating a type confusion in the UAF scenario.
yeah. So yeah, I mean this is basically a really good write up on type confusion and how it can be used. And I mean, that's going to be universal across not just iOS, but like any device you're trying to do memory corruption on. So even if you're not particularly interested in iOS, I would recommend trying to give this a read. Some of it might be a little bit like tough to read, and you might have to jump around a little bit if you're not familiar with like kernel stuff or iOS stuff. But I mean, like you said earlier, it's still made very accessible. Like I don't do any iOS research at all, and this write up was pretty accessible to me. So yeah, I really recommend it to anyone who's interested in memory corruption and wants like a an interesting read on something they might not be familiar with.
Yeah, on the exploit dev side itself, this was a really good write up. Also, as you were just going into the type confusion aspect, I mean the fact like the info leak thing, using kind of the secondary derived, almost second order type confusion. um, Kind of going with that road, like that is kind of common when it comes to escalating a primitive. Use one primitive to create kind of another scenario. Um, Going the type confusion route there is fairly common. I mean, I guess we're using type confusion very loosely, I guess, with that too. Um, yeah, I mean, on a whole, I like this post. I want to bring something up because I feel like I may be just losing my mind a bit, but uh in this code, like this, using the double colon, does C support that? I was seeing that, I'm thinking C++.
I believe it is C++.
Um
And I'm just
yeah,
basing that
okay.
off the fact that Apple is one of the vendors that likes to utilize C++ in the kernel. And I believe IOSurface is like completely C++ based. So
Yeah, because obviously we see plenty that looks like actually, yeah, because they talked about the V table. I'm sorry, it was just out of chat. One of the users just mentioned it's C, and I'm like, am I going crazy? Like, I was sure this is C++, but then, you do. Obviously, there's some things that look very familiar with when it comes to anything in. Well, I guess this is probably maybe symbols, but decompiler still, perhaps. It has
yeah,
symbols, but V5 is not code written. And yeah, I mean, C and C++ are going to look somewhat similar in a lot of places, given the background there. I thought I was going crazy there. I'm like, does it support this? Yeah, okay, we're good. I just wanted to clarify that for a moment.
yeah, that is a good point to bring up. Like we are dealing with reversed code again, because it's Apple, so of course we are. But um,
I mean,
yeah,
XMU is
Apple.
open source, so I mean, some of the core is available.
Yeah, it's very Apple. Like you get maybe like 30% of the code is like you can read it. The rest of it you're on your own. Um,
So MyoCat just asked. Sorry, I did interrupt you there, but so it is it C++? I'm pretty sure it's C++. When it comes to Objective C, that breaks down, I think, to C++, not C. I'm probably wrong about that. You know what? I don't even want to hold to that statement because it has been so long since I've worked with Objective C.
yeah, it is a superset of C. So yeah, I can't really
Oh yeah,
comment there
C
too
with
much because
extensions. Yeah.
yeah, Objective C is just not something that I like very much. So I never put any time into
Who
figuring
wants to
out the.
type all those square brackets?
I hated Objective C when I tried to write it. It actually put me off completely from doing any like iOS app dev because there was a point in time where I was interested in it, and then I looked at Objective C and I'm like, nah, I'll go do something else.
Yeah, just back away.
Yeah, back away slowly. Um, but yeah, another thing I would pull out of chat, like Tony Watt says, Microsoft uses C++ as well, from what I recall. Yeah, so Microsoft and Apple are kind of the big two that are proponents of C++ on the kernel.
They're also kind of the
I
big
kind
two
of,
operating systems and kernels out there. I mean, there's
yeah,
Linux, obviously, but
and I was just
Linux
about to bring up
BSD.
Linux, because I would kind of fall in line with Linus's view and the way that I don't agree with putting C++ on the kernel. I don't want to start a language war, but I just don't think it's a good idea to put such a complicated language into the kernel where it doesn't need to be. But obviously Apple and Microsoft have different perspectives on that, and they freely put it in there. So whatever. What do I know?
Productivity. I
Yeah.
I personally, I don't care all that much. I mean, developers are going to develop. Might as well give them the tools they need.
Yeah. It's just that with C++, you do find things like type confusions and stuff becoming more commonplace just because of how object oriented C++ is. That said, I mean, like kernel C code is object oriented as well. Like it's kind of like a hacked C++ in a way, like using function tables instead of e tables and whatever. But yeah,
Well, the ops tables, yeah. I mean, C doesn't support it natively, but programmers still want some of those concepts of inheritance, still want some of that, and they implement it into C also. Um, yeah, I that's kind of where I kind of fall on the side, like, whatever. Let developers, they're still responsible for the security of their code.
yeah, that's a good way of ending it. Um, but yeah, like I said, like anyone who wants to read some stuff about memory corruption should definitely check this out. With that said, that's pretty much all the topics we have for this week. Thank you, everyone who tuned in. The VOD will be up on Twitch immediately or on YouTube tomorrow. We also have previous podcasts up on Spotify, Apple Podcast, and more platforms that are centralized through Anchor. For alerts of when we're going live and to join the community, follow our Twitter and join our Discord. Links for those are down below or in the chat. We'll be back next Monday at 3 p.m. Eastern, 12 p.m. Pacific for bounty stuff, and next Tuesday at 7 p.m. Eastern, 4 p.m. Pacific for binary stuff. Another reminder before we head out, we will be going on a 3-week-long break in December. Our last 2 episodes before that are December 13th and 14th, and we'll be returning January 10th and 11th. And yeah, with that out of the way, we'll see you next week.